Alright guys, let's take a look at some of these. Any right triangle, okay, sides A and B, hypotenuse C, the area is always equal to 1/2 of A times B. You need to remember that with those problems, okay? You need to remember, I guess this is going to be a 5, 12, 13, your triplets there. Here's your special right triangle 30, 60, 90, and 45, 45, 90, so you need to remember that. In this diagram, A is equal to 4. So if A is equal to 4, this is an equilateral triangle, okay? Then here's my 60 now, here's my 30, here's my 90. So this length is now 2, this is 2 root 3, so area of the entire equilateral triangle is 1/2 of the height, which is 2 root 3 times the base, which was 4. Okay, so multiply that out. Okay, and the next one is done the same. All right, let's look at a couple more of these. Okay, the area of a trapezoid, you need to remember is 1/2 the height times the sum of the bases. So if this is our height, then our bases are QT plus RS. The bases are the parallel sides. You need to remember that, of course, okay? And the height is the distance between the parallel sides. That's what's going to apply here. Let's see. The height is 8. This is 8. And AB is 5. And DC is 11, so this entire length is 11. Oh, we got everything we need, just plug it in, okay? Pretty much probably going to find that for the rest of those. The isosceles trapezoid, this one will be interesting. DE is 26, EF is 40, and DG is 20, okay. So it looks like if you pull those up, that would represent the height. So you have to find the height. And if this is 20 coming up, this is 20 in here, and this is evenly split at 10. So you should, I think that looks like a some kind of a 5, 12, 13. Yeah, it's a 5, 12, 13 double. All right, which means you should be able to find that missing side each is 24, after which you should find the area. Okay. Same thing follows for these. The parallelogram area is equal to the height times the base. All right, and the height here is, again, the distance between the parallels. And you can see that if you take that, cut it out, and bring it over here, it makes for a rectangle, which kind of justifies the reason for the height times the base, same as the area times for a rectangle. Okay, so of course here you need to use 30, 60, 90 principles. All right, ST is 6, TU is 8. Okay, that's the angle. So the half of 6 is the short side, which is 3, so that's the height, so the area is going to be 3 times 8 for 24. Okay, another 30, 60, 90 coming into play there. Okay, and more parallelograms. This is going backwards. This is saying that if you have the area, which is 400, and you need it h times, which is the height, okay, and that's the distance between the parallels, okay, trying to right angles if you look at it that way, or if you look at it this way, okay, but nonetheless, they give you the height, so, and then they give you at the base, which is AD, so 20 times what is 400, this sounds to me like another 20 for the height, okay. Now the rhombus, okay. If you remember, special formula for the rhombus is 1/2 the product of the two diagonals. So the area in this case is 1/2 of PN times N. Oh, all right. And I think they give you this, and it's just a plug-in. All right. Um, rectangle should be no problem. Here, the rectangle is inscribed in a circle. What is the area of the rectangle? Okay, well, let's see. Take the information that they give us. They give us that the diameter is 10. The diameter is 10. Okay? And the AB is 8. I guess that's a 6, 8, 10. So it looks like the area of that rectangle is going to be 60. Okay? All right. The area of the regular hexagon. Okay? Area for regular polygons is 1/2 the apothem times the perimeter. Okay? Which means here, again, we've been doing these over and over again. We got to look at that triangle. That triangle has a central angle there, which is 60 degrees. Okay? Of course, we want to break that down and cut it in half so we can apply the 30, 60, 90 principle there and find the apothem. Okay? The perimeter is easy enough to find. Every side is 4. There's 6 sides, so the perimeter is 24. That should be no problem. Okay? If the ratio of the areas of two similar triangles of 4 to 9, we remember. Okay, let's take just a brief reminder of this. Okay, it's a square, poor excuse for a square, I guess. Okay. Say this is 2 by 2, so the area is 4. Say this is 3 by 3, so the area is 9. So the ratio of the areas is 4 to 9. Okay. What is the ratio of their sides or their heights? Well, okay. So the ratio is the similarity ratio, which is the square root of that 4 to 9 ratio. So if you have the area ratio, the similarity ratio is the square root of that, which in this case would be 2/3. Okay. Whether I drew these as triangles or rectangles, it doesn't matter because we're talking about the ratio of their areas. So, and that's it. Okay, so you certainly should be able to complete that and then be tested on it. There you go.